Alright, let's take a look at this, the end of chapter 11. Let me see if I can get in the right mode here. There we go, and let's click on that. Good. Alright, let's see what we've got here. We have to find the area of this figure. So it's all shaded in and stuff, so you're finding the area of that whole entire figure. It's basically a square and a triangle. So let's find the area of this square, or this parallelogram. So if all the sides are equal to each other, it's just 6 times 6, which is 36. So that's the area of just the square. Now let's find the triangle. Now watch, if this whole thing is 8 and this part right here is 6, this little bit is 2. Now obviously it's not drawn to scale, and that's fine, but that's what that number would be right here. And the height of this, of course, would be 6. So the area of a triangle, let's just do it right here, the area of a triangle is 1/2 the base times the height. So it's 1/2 the base, which is 2, times the height, which is 6. It's the height because it's perpendicular to the base. And then you just do that. Half 2 is 1, 6. Okay, so the area of this is 6. Again, obviously not drawn to scale. So 36 and 6 is 42, and that's the total area. So area is 42. It's centimeters, so it's centimeters squared. I'm not going to be picky about putting centimeters squared right there. Alright, let's go to the next one. Alright, here's another one. Still, it's like a combination of two things. And so you find the area of this, find the area of this, add them together, and you got the whole area. So this thing right here is a rectangle. So first thing is the base times the height. So I know what the height is at 6.6, but what's the base? Well, the base is from here to here. That's only the rectangle. But look, that 14.3 is larger than this right here. Let's see, how in the world can we find from here to here? Well, if this is 6.6, this one right here is 6.6 as well. Alright, so from here to here is 6.6. Let's take a look at something here. What is the radius? Alright, because look, if I go to here, that's that distance, right, from here to here. Okay, that's the distance. What is that distance? Well, it's the radius of this semicircle. Well, the whole diameter of the semicircle is 6.6, so the radius is half of that, which is 3.3. So that distance right there is 3.3. Alright, from there. So how do we find just the rectangle? Well, we take 14.3 minus 3.3, and that would be 11. Alright, so that's the distance from here to here. Now we can go ahead and find the area of this rectangle. It's just base times height. 6.6 times 11. And I just did that in my calculator, and it's 72.6. That's equals. That's not the answer, though. Okay, that's actually, I don't like to circle it. I like to just circle it when it's the final answer. Put it in a box. Okay, so this rectangle right here is 72.6. So now what we have to do is find the area of the semicircle. Then we can add the semicircle to the rectangle, and then we should get our final answer. So let's find the semicircle. Well, the area of a circle is pi r squared, but if it's a semicircle, it's half a circle, so the area of the semicircle is pi r squared divided by 2. Pretty simple. Let's figure out, what is the radius? Well, we just finished saying that the radius is 3.3, so it's pi times 3.3. Got to square it, because we square the radius, and divide it by 2. This is definitely a place where you can use the calculator. That was the other one. Alright, so it's 3.3 squared. You could do pi first if you wanted to, doesn't make any difference. 3.3 squared. Pi, or times pi, depending on your calculator. Oops, wrong button. Let's try that again. There we go. 3.3 squared times pi. That whole thing is divided by 2. There you go, 17.1. We'll round it. So the area of this semicircle is 17.1. Alright, so now what do? Pretty basic. Just add those two together. So 72.6 and 17.1. That's an 8, that's a 9, that's an 8. So 89.8. Now, for some reason, I have 89.7 on my answer key, probably because maybe, I don't know, I probably took this whole answer and added it to 72.6. Let's see. Take that whole answer and add it to 72.6. Let's see what we get. Yeah, we get 89.7. So it would be fine. It's just, on this one I just rounded And so 89.8, 89.7, basically the same thing. I'd be fine either way. Alright, let's do number 13. I don't think I need to put the question actually in front of you. If you're following along, you probably have your test in front of you anyway, but I'll just read it off. It says the area of a rhombus with a perimeter of 100 meters. So let's write that down. We have a rhombus. Now a rhombus means all four sides are equal, and then the perimeter is 100 or 100 meters. And one diagonal has a length of 48. One diagonal, I'll call it D1 for diagonal. And that's 48. Alright? And we want to find the area of this thing. Okay, so find the area of this rhombus. Let's see how I want to do this. You know what would be best? It would be best if I actually drew this thing out. So let's actually draw a rhombus. Alright, I went over and copied. Now I paste. There's a rhombus. Just make things a little bit easier for us to visualize what's going on. I normally have to look at these things. I don't like to do a lot of these in my head because I get confused and it gets all mixed up. So let's figure this out. Now if the perimeter, now rhombus, all four sides are equal. If the perimeter is 100, then how do we find each side? Well, we take 100 divided by 4, and that would be 25. So that length right there is 25. All the lengths are 25, but the diagonal is 48. So let's draw a diagonal right here, and we'll label that. So that diagonal is 48. And we want to find the area of this thing. Well, how do you find the area of a rhombus? Well, a couple ways. You could find the, let's do this. Let's do another diagonal, because we have another equation with the diagonal. So let's do that. That would be helpful to us. Let's do that, okay? Alright, so what do we know about a rhombus? Well, a rhombus, four sides are equal, so all four sides are 25, so we already talked about that. We also know that the diagonals of a rhombus are perpendicular, so we know we have a right angle. We also know the diagonals of a rhombus or any parallelogram bisect each other. So I know one of the sides of this, so I know that is 24. Alright, so I know this side right here is 24, and I'm trying to find the area of this diagonal, or this rhombus, I'm sorry. So we need to find it. We should have started off with this right away. We have an area formula for a rhombus. It's 1/2 the product of the diagonals. Now, you could also find the area of a rhombus since it's a parallelogram, the base times the height, but it's going to be very difficult to find the height in this situation. So I think this is the best one because they give you a diagonal, and you got diagonal right here. So really all we have to do is find the other diagonal. So we've got this information right here, so let's find out what the other diagonal is. Now, remember this 48, I'll tell you what, let's get rid of that because that could get confusing. That 48 is the length of this diagonal right here. So what did I do? I split it in half, so that's 24. We already know this is 25 because the perimeter is 100, we divided it by 4, we got 25. So it would be really nice if we knew this one right here. So one of the diagonals is 48. We already talked about that. Let's plug the stuff in. So 48 times the other diagonal. So that's really what we're trying to find here, is this whole entire diagonal. Well, I know this side from here to here. You could do it by Pythagorean theorem, or you could remember the triples, the ordered, what do they call those? Pythagorean triples. And one of them says, remember 3, 4, 5 triangle, 5, 12, 13, those kind. Here's another one that's not quite as familiar, but it's nice to know it. So it's a 7, 24, 25 triangle. If you didn't know that, that's fine. Do Pythagorean theorem, you'd go 25 squared minus 24 squared, then take the square root, and that's going to give you 7. So that's 7 right there. But that's not the whole diagonal. What would the whole diagonal be? Well, that would be 7. This whole diagonal is 14. So there's the two diagonals. 1/2 times the first diagonal. They told you that one right off the bat. And then you just had to find the second diagonal. So what we did is we drew both diagonals, knew that it was perpendicular. We knew this was 25, we knew this was 24 because it's bisected, and then we just figure out what this is. This is 7, this is 7, the whole thing's 14. Plug all that stuff in, and you should get 336. And whatever it's in meters. You can go meters squared if you want to. You don't have to. I'm not going to take off if you do. Alright, hope that makes sense. Alright, here's another rhombus problem, number 14. It says the area of the rhombus is 49. Area of the rhombus is 49. It's millimeters, so it's millimeters squared. That's the area of a rhombus. Let's write that word down so we know which picture we're talking about. So the area of a rhombus is 49 millimeters squared. It says if one diagonal is twice as long as the other one. Remember the two diagonals, we call one D1, we call the other one D2. Those are our two diagonals. So if it says if one of the diagonals, let's say D1, doesn't really matter which one you pick, but if you say one of the diagonals, D1, equals twice as long as the other one, twice as long as the other one, see there's one diagonal equals twice as long as the other one, what are the lengths of the two diagonals? Alright, well we have a formula, don't we, for the area of a rhombus. We just finished doing it. So it's 1/2 D1 times D2. It's not plus, it's times. Make sure you remember that. So let's plug some stuff in. Look, area. Well, I know area. It's 49, so I'm going to take that 49 and put it in for there. So it's 49 equals 1/2 D1. So this is what I'm using right here. What's D1 equal to? Well, D1 is equal to twice D2. So let's write it like that. So it's times 2 D2. Alright, so that's the D1 right there. That's D1. Then I got to multiply that by D2. Well, I'm just going to, since D2 is my variable, I'm just going to write it as D2. So that's a little strange looking, but let's see what we get. Let's just do the math. 1/2 of 2 is just 1, so really that cancels out. So what do we get? We get 49 equals, this is D2, but it's D2 times D2, which is D2 squared. How do we get D2 by itself? Take the square root of both sides. That'll cancel out. Take the square root of that. So what's D2 equal to? It's equal to 7. The square root of 49 is 7. So that's one of them, but it says what are both? What are the lengths of the two diagonals? So that's one of them. What about the other one? D1. Well, remember, D1 was twice as big as D2. So D1 is 2 times D2, which is 7. So D1 equals 14. There you go. Just have to understand what that means. The hardest part was understanding that D1 was equal to twice D2. That thing in the box right there, probably, in my opinion, was probably the toughest part of that problem. So make sure that you understand how to do that. Alright, let's do number 15. Okay, number 15, it gives you the area of a circle. So I'm working with circles this time, and it tells you the area of that circle, and it's 63.6. 63.6, and it's square feet. So they tell you the area. It says to the nearest tenth, what is the length of the diameter? So I'm going to put D equals question mark. Well, look, I'm not directly going to solve for diameter. I'm actually going to solve for area. And how do I know to even do that? Because I have a formula for the area of a circle. Since they tell you the area of the circle, I would like to know what the formula is for area of a circle. And it's pi r squared. You don't see diameter in there at all. You do see the radius. So what I'm going to do is I'm going to solve for the radius, then I can find the diameter. That would be easy. If I know the radius, I just double it, and that's going to be the diameter. So let's plug some stuff in and see what we can find. Do I know what A is, the area? Yeah, they told it to me. 63.6 equals pi times the radius squared. I don't know the radius, that's what I'm trying to solve for. 2 steps and you'll be done. Divide both sides by pi, so divide that by pi, so the pi's cancel out. R squared equals this. So if I want to solve for r, I have to take the square root of both sides. So take the square root of this side and take the square root of this side over here. See, that squared goes away. So that is what the radius of that circle is. But we're still not finished because they don't ask for the radius, they ask for twice the radius. So, I don't know, if you wanted to, watch this. You could have done this. You could have just stuck a 2 right there and plugged all that into the calculator. Why don't we do that? That probably is a good idea. So let's do all this stuff first. I'll get an answer for that square root of all that. Then at the end I'll multiply it by 2. It would have been the same way the other way. Anyway, 63, a lot of ways in there. 63.6 divided by pi, right there, equals, we'll take the square root of that. So take the square root of that answer. Okay, that's what you get. Now you could round it and then multiply it by 2, but I'm just going to take that whole number, multiply it by 2, and see what we get. So multiply that by 2. Again, why did I multiply it by 2? I multiplied it by 2 because what I'm doing here is I'm solving for the radius. But I want to find the diameter. See, d equals. I want to find the diameter of this circle. So I just multiply it by 2. So 8.998, or what does that round to? Looks like it rounds to about 9.0. So the diameter is 9.0, or just 9. It's fine. So it's in feet. That's the diameter of that circle. Alright, hope that made sense. Oh, I thought I was getting to the end because it was at the bottom of the paper, but remember, this is that test where I did 2 papers, because the second part, I drew the pictures pretty big, just so you can see them pretty well. Alright, so let's do number 16. Alright, here we go. We're trying to find the area of the shaded region. Because we know the area of this one right here, we just have to find the area of this. So I'm going to put A equals question mark. You could put like an A2, right? Call this A1, call it A2. Doesn't make any difference. Well, you got to just remember the rule. First of all, here's my particular rule. If I'm trying to solve for A, I think it's always easier that don't compare the left side to the right side every single time. If I'm trying to solve for A, I'd put that on the top. So let's put that on the top. So what's our formula say? Our formula says we can compare the areas. It doesn't matter which direction we compare them, right? As long as you compare the sides in the same order. So if I compare the shaded side to the non-shaded side, it's A over 500 equals, because this is a proportion. Now we also have the sides that are what's the word? Starts with C. Corresponding. That's right. Man, for some reason my mind goes. Anyway, they're corresponding. So is this side corresponding to this side? Well, sure it is. It says the figures are similar, so this and this would be the same. Nah, I wouldn't say that. But if they're similar, then these two sides are the ones that they give you. They're the ones that match up with each other. So watch what I'm going to do. If I compare the shaded to the non-shaded, or the right to the left, I have to do the same thing with the sides. But I don't just put 15 over 20. Remember, I have to put 15 what? Squared over 20 squared. Why do I put the squared there? Because that's what my formula tells me what to do. Right? It tells me I've got to compare the square of the sides, the corresponding sides, and I compare the areas to each other. I don't have to square the areas. Let's see how to solve for A. Pretty simple. Multiply both sides by 500. Multiply that by 500 and throw that into a calculator. So you get 15 squared times 500 divided by 20 squared, and hit equals 281.25. It says round it to the nearest tenth, so if it's 0.25, we'll round it to 3. So it's 281.3, and that's why I wrote that answer if you got it wrong. Alright, let's do another. Number 17. Alright, let's take a look at this. This is kind of the same thing, except we're not solving for the area. By the way, this is area equals 100, and this is area equals 40. They're not the lengths of the sides. The area of this trapezoid and the area of this trapezoid. Well, it looks like a trapezoid. I'm not sure if it is or not, but it doesn't matter. It's a 4-sided figure. Let's see, we have, and they are similar to each other. That's what they tell you. That's what's important. What are we trying to solve for? X. So I want to put that on the top. So I'm going to compare x, what? Not just x, but x squared to 5 squared. So I'm going to go x squared over 5 squared. So if I compare the right side to the left side, let's do the same thing with the area. Now I don't have to square the area. And you say, why not? Well, it's because it's not in our formula. So this is x squared over 5 squared. This is just going to be 40 over 100. Now we solve for x. Multiply both sides by 5 squared. Oops, let's make that a little smaller, make it look like a square. And then we take the square root to get rid of that squared. Looks complicated, but it's not hard at all. It's a simple relationship. X to 5, okay, one side to its corresponding other side, squared, don't forget, to square those two. And then you just compare the areas to each other in the same order. If I went right to left, this has to go right to left. Alright, so let's put some numbers in there and see what we come up with. Alright, it's 40 times 25, because that's 5 squared, divided by 100. Alright, that's 10. And then you take the square root of it, and the square root of 10 answer equals 3.2. Yeah, we'll just say 3.2 because it says rounded to the nearest tenth. So x is 3.2. Alright, we're almost there. We're getting there. This is the last 3 that I have to do. I've done all the other problems for both classes. So if you think you've worked hard, I worked hard on these myself. Alright, let's do... let's draw a triangle. Give me a second while I draw this triangle. Alright, let's take a look at this. Isn't that a nice pretty picture I drew right there? Alright, it says find the area of the shaded region. So we're trying to find the area of the blue part. Assume the triangle is equilateral. Alright, so it's a equilateral. It's a regular polygon. Alright, and we want to find the area of the shaded. Well, first thing we're going to do is look at this. They give you this length right there, and they say that is 10. Alright, so that's the length from there to there. That's also the radius of that whole circle. So we could start off, what are we going to basically do? We're going to find the area of the whole entire circle, then find the area of the triangle, take the triangle away from the circle, and we've got the shaded region. Alright, so the area of the circle is pi r squared. R is 10, so that would just be 100 pi. We'll just leave it right there for a second. Alright, that's the area of the whole circle. So what we're going to do is find the area now of the triangle and take it away from that 100 pi. So how are we going to do that? Well, we do know that the area of the triangle is 1/2 the base times the height. But I don't think that's going to help us here. Remember, this is a regular polygon, right? Because it says it's an equilateral triangle. So we have a formula for that, which is 1/2 the apothem times the perimeter. It's supposed to be a p. Let's make it look like one. Okay. So I don't know either one of those right now, but I think we have an idea of how to do this. So what we're going to do is we're going to drop this straight down, just like that. Got a right triangle, so that's going to help us, and that's the apothem. And let's just call this x right there. And we need to find x in order to find the perimeter, and we need to find the apothem. So how does that help us? Well, it helps us because I know an angle in here. This is equilateral triangle, so this angle's 30, this angle's 30, and this whole big angle is 30 right there. This line right here bisects that angle, so, I'm sorry, did I say 30? I meant 60. 60, 60, and 60. I was getting ahead of myself because we're going to bisect that 60 and we're going to make that into a 30. So it's a 30, 60, 90 triangle. The hypotenuse is 10. The apothem is the short side, so the short side is half the hypotenuse, so that is 5. So I know, right there, I know the apothem is 5. Let's just get rid of that A, and let's just get rid of the 5 and move it a little bit closer. Put the 5 right there. So that's the apothem. Now what we have to do is find the perimeter. So it'd be nice if we knew the length of this right here, of x. And we should, because we know the short side. This is the longer side. It's opposite the 60, so this is 5 times the square root of 3. But look what we have here. Let's change colors here. So the area is 1/2 the apothem, which we found, which is 5, times the perimeter. Let's find the perimeter of this triangle right here. Well, I know this side is 5 squared of 3, so I know the whole entire length is 10 squared of 3. How many sides do I have? I've got 3 sides. So I could take the 10 squared of 3, multiply it by 3, because there's 3 sides, so that would be 30 square root of 3. So the perimeter is 30 square root of 3. Hope that made sense. Or you could look at it like this. This is 5 squared of 3. How many of these half pieces are there? There's 1, 2, 3, 4, 5, 6, or 6 of them. Or I multiply it by 2 to get the whole thing, multiply it by 3 to get everything. So basically it's 5 times 2 times 3. 5 times 2 is 10 times 3 is 30 square root of 3. I hope that makes sense to you. So that number right there, that crazy number, and let's figure out, let's make this a little bit easier. Half of 30 is 15, and then 15 times 5 is what? 75 times the square root of 3. So that's the area of the triangle, 75 square root of 3. And what am I trying to do? I'm trying to take the area of the circle, which is the whole entire thing, and take away the triangle. This is the triangle, this is the circle. So basically, this is what I'm putting into the calculator. I'm putting in 100 pi minus 75 square root of 3. So let's put that in here. So turn it on, let's clear everything. 100 pi, you should be able to do that in your head actually, because 3.14, just stick a couple zeros on there, that's 314. Let's see if it is. Sure it is. And it goes more. We'll use that whole number. Okay, minus 75 square root of 3. So we'll take that answer and subtract 75 square root of 3. And then we get 184 point about 3. It depends on how far you rounded it and all that kind of stuff. Some people would have taken 75 squared to 3, rounded that. They probably would have got a decimal for this number, a decimal for this, and subtracted. Either way, 184.2 or 184.3 would be perfectly fine. I think I wrote down 184.2, probably because when I first did it, I probably put this into a calculator, rounded it, put this into a calculator, rounded it, then subtracted, and then I probably got 184.2, right? Or 184.3, because that the other way actually rounds it up. I think that's probably good right there. All right, let's do another one. Number 19. All right, this is kind of like what we just did, except it's not a triangle. It's just a little bit more complicated, but it's basically the same kind of problem. Except it's a hexagon. 1, 2, 3, 4, 5, 6. Yep, it's a hexagon inside or inscribed in a circle. And we have to find the area of the shaded region again. And again, it says assume the hexagon is regular, which means all the angles and sides are equal. So what do we have to do? Find the area of the circle. All right, we've gone through that before. Let's try not writing in black because that doesn't show up very well. Let's try this color, just kind of orange color. So what are we doing? The area of this circle. So the area of the circle is pi r squared, which is 8 squared, and 8 squared is 64, so it's 64 pi. We'll hang on to that and then come back to it. Now we have to find the area of the hexagon. That's really the part that's a little bit tricky. Let's use the black right here. And what we're going to do, drop down a perpendicular, because that's the apothem, because I want to find the area of this hexagon. So it's 1/2 the apothem times the perimeter. So I need to set that thing up. Now this is a hexagon, so what we're going to do is we're going to find that angle right there. So I go 360 divided by 6. 360 divided by 6 would find this angle right here, the whole big angle. But I only used the big angle to find the smaller one inside this right triangle, so I can use it and do some math with it. So if this whole thing is 60, 360 divided by 6 is 60 degrees. That's that whole angle. What's this angle right here? Well, this angle would be 30 degrees. Now if this is 30 and this is 90, then that has to be 60. So another 30, 60, 90. Let's change colors so I can start seeing this. What was I thinking? Okay, this is the hypotenuse, so what can we find? That's basically the apothem, and we want to find the perimeter of the whole thing, so we want to find this. Very, very similar to what we did with the triangle, just a few more sides, that's all. In fact, 3 more sides. The apothem is the long side this time. Okay, this down here is the short side, so the short side is half of the hypotenuse, so that's going to be 4. Alright, so that's kind of nice. And then the apothem is just 4 times the square root of 3. So short side times the square root of 3. So let's write our little formula down. The area of the hexagon is 1/2 the apothem times the perimeter. So I just found the apothem. That wasn't hard. 4 square root of 3. And I have to multiply it by the perimeter of this hexagon. Well, look, this little bit from here to here is 4, so from here to here is 8. So that whole thing from here to here is 8. There's 6 sides. 6 eighths are 48, and that's how you get 48. That's the perimeter of the hexagon. Again, I found this half of it to be 4. That means the whole side is 8, so there's 6 of them. So 8 times 6 is 48. And then you could just put that all into a calculator, but let's just do it like this. Watch, half of 4 is 2. 2 times 48 is what, 96? So that's 96 square root of 3. Put that in a box. So what do we do with these two? We subtract them from each other. So I've got 64 pi minus 96 square root of 3. Again, like on the triangle problem that we did earlier, you could have put this in a calculator, got a decimal, put this in a calculator, got a decimal, then subtracted those, you might get a slightly different answer, but it's not going to be off much, if it's off at all, just because we rounded earlier than we are right here. So 64 pi minus 96 square root of 3. 96 square root of 3, and that's about 34.78, which is about 34.8, and yeah, that's exactly what I said it was, 34.8 on the test. Alright, now it's in inches. You could put inches squared, but again, I'm not really concerned that much about that part of it. One more. This is it. This is the last one. You think you're excited? I'm very excited about this. In fact, if anybody's even listening to this, I have no idea. It says if one diagonal of a rhombus. So let's draw a rhombus. Alright, this one's actually it's very similar to one we did earlier in the test. It says if one diagonal of a rhombus is 15 meters long. So let's draw one of the diagonals. Doesn't matter which one. It doesn't have to be to scale necessarily. So if that's 15, and they tell you the area of that whole entire rhombus, which is 157.5, what's the other diagonal? Oh my goodness, this one's actually pretty easy. You don't even need a picture for this. So the first diagonal is 15. It's asking what is the other diagonal. Well, we have a formula for that. We've already seen that formula once today. So it's d1, 1/2 of d1 d2. A lot of people forgot that 1/2. Don't forget that on a rhombus and a kite, it's 1/2 d1 d2. And let's put some numbers in. We know the area, so that's 157.5 equals 1/2 d1, which is 15, and then we got to find the other diagonal. That's d2, so we put d2 right there. Alright, so what can we do? We could multiply this by 2, right? Instead of taking half of 15, I'm going to multiply that by 2 and then divide by 15. It's the same thing. So let's put some numbers in and we'll be finished. We're almost there. So it's 2 times 157.5, and divide that by 15, and that gives you 21. It's exactly 21, which is kind of nice. No decimals or anything. It's exactly 21. And that's it. So that's chapter 11. That's everything. Now I just got to put everything on YouTube and hope some of you guys watch it. Alright, that's all for now. Bye.